Okay, good afternoon, everyone, and thanks for joining in. And agenda for this revision session is to carry out revision of week 8, and then we'll solve PYQs for corporate finance towards quiz 2 of this BS program. So I'll just share my screen. Just let me know when my screen is visible to all of you.
Yes, it's visible.
Okay, very nice. So first we'll go through the week 8 basics. So week 8 basics, see, till week 7 we had seen the portfolio where there were two assets and we had to find the expected return of those assets and then find the standard deviation of those assets. Now in the week 8 what we have done, we have now come to combination of these assets that we might be having one risky asset and one risk-free asset. Okay, or we have got, for example, two risky assets. So if we have got two risky assets, so this is the formula which gives the expected return. Expected return will be weight 1 of expected of rate 1 and plus weight 2 into the expected rate 2. So, and your formula for standard deviation and variance, it remains the same, which we had covered yesterday. Okay. And we also know that weight 1 plus weight 2 is 1. So by putting W and 1 minus W, we can find the expected return. And once you make this expected return in this line, for example, when we put W into ERP plus 1 minus W, so we get a linear equation. So this is a linear equation where the slope is ERP minus RF. Now here one new term has been introduced, which is Sharpe ratio, and Sharpe ratio is defined as ERP minus RF. So this is the case where we are having one risky and one risk-free. So RF is the risk-free element, RP is the risky asset, and W is the risky weightage, and 1 minus W is the risk-free weightage. So when you do this, you get a linear equation, and when you define that Sharpe ratio. Sharpe ratio is nothing but expected from the risky asset minus risk-free divided by standard deviation of the portfolio. Now remember, when you have got one risk-free and you have got one risky asset, so standard deviation or the variance of the risk-free is always 0. And your total standard variance of the portfolio is nothing but W square into RP square. Oh, sorry, this is so let me make this risky asset as RC square, and standard deviation is W square into RC. Okay, so we have to remember this formula, that what is the meaning of this Sharpe ratio. And now if you replace this ERP minus RF can be replaced by S into sigma P. So your expected total RC will become RF plus W into S into delta P. So this is another equation. So if you have understood the concepts, then you can play around with all these equations easily. Okay, is this clear with everyone?
So sigma p is W square into RC, right?
Yeah, okay. So this will become S into sigma P, W as sigma P. And now this W into sigma P, which is there, this also can be replaced by sigma C. Is that okay?
Once again.
Okay, so just hold on. I will just cover it here. So we have got two assets. One is A. This is risk-free.
Okay.
Risk-free. This is 0. We have got another asset which is risky. This return B is equal to, let's call it as R P, for example, and this
Okay.
B is equal to sigma P. Is that okay? So now we can
Yes.
write expected total RC is equal to weight into RP plus 1 minus W RF. And when we use the expected here, because this is a risky asset, so I have to use expected. So here I get expected RC is equal to, when you open this, this will become RF plus W ERP minus RF. Is this okay? This formula? So this is a
Okay.
linear equation. Okay. Now they have introduced a new term, which is a Sharpe ratio, which is defined as ERP minus RF divided by sigma of P. Therefore, ERP minus RF is equal to S into sigma P. Is this okay? Now you use this in this formula, that ERC is equal to RF plus this position can be changed by this S sigma P. So this will become W into S into sigma P. This is one equation. Is this okay? And your now your
Yes.
total standard deviation which is there is equal to W into sigma P. Therefore, you can
Yes.
write down ERC is equal to RF plus S into sigma C. This is the final equation you get.
Got it. Yeah.
Okay?
Yeah. Now clear.
Yeah. And this final equation which is there, this is also known as CAL. Okay? It is a capital allocation line. This equation which we just arrived. And if you draw it, then you can start from RF. When sigma C is 0, that is the time you will get only RF. Now, when you increase it and you keep on increasing sigma C, so your expected RC will start increasing. So this is the cap. Okay.
Yes. Yeah.
Okay. So you can be asked to formulate a calculation. So we should be ready how to find the calculation. We can do that. Now, in this case, I have to find, for example, W star. W star. So W star, I can find from this equation. This will become E of RC minus RF divided by S into sigma P. This is okay?
Yes. Yeah.
Okay. Now, this ERC which is there, this ERC I can find from RF plus W into ERP minus RF. This was the formula. And I do RF S into sigma P. Is this okay?
Yes.
Okay. So here we will get W square is equal to RF. RF will cancel out. Okay, just hold on, just hold on. I have committed some mistake somewhere. W star formula will come derived. I will just come here. Why I'm doing, because see, if you forget the formulas also, we should be able to do this. I will come
Through
to W
derivation.
star through derivation. Okay, so it is like this. So it is coming from the W star. W, though you can calculate from here directly. If anything is given, you can find the W from here. Okay. But when you are given a utility function, so utility function is generally given by something like that your total expected RC minus half A into sigma C square. The utility function is in this format. Okay. Standard
Yeah.
utility function. Now to have the maximum utility, I have to find like a W star. So I can write this as E is equal to ERC is nothing but RF plus W into E of RP minus RF minus half A. WC square also I know it is W square into sigma P square. Okay, now I take this derivative with respect to W. So this will become 0. This will become ERP minus RF. This will become minus 2A into 2W into sigma P square. Therefore, if this is the optimal W star, which is increasing the utility, so your W star becomes ERP minus RF divided by A into sigma P square. Is this okay?
Yes. Okay. Yeah.
Okay, so this is the formula for your W star. Just give me a second, huh? I will say.
Yeah. Sure.
Okay, I'm back. Okay, so we have found like now the calculation. We have also found W star when there are only two assets. One is risky and one is risk free. We also deliberated on the formula for Sharpe ratio. Is that okay till now? Everything is good?
Yeah. Well and good.
Yes.
Now we go to the second scenario where there are both are risky assets. So both are risky assets, A and B. This is R1, this is R2. This is risky, so it will have some standard deviation. It will have standard deviation. Now for this, the expected return will be equal to W into R1 plus 1 minus W into R2. This is okay. Number one. Number two, the full variance of this portfolio will be equal to W into sigma 1 square plus 1 minus W square into sigma 2 square plus 2 W1, W2 and covariance of 1, 2. This is okay.
Yeah.
Okay. Now what we can do, we can expand this. So we can write it as W square sigma 1 square plus 1 plus W square minus 2W into sigma 2 square. This will become 2 into W into 1 minus W. And for example, if you are not given the covariance and you are given the correlation coefficient, So this will become correlation coefficient 1, 2 into sigma 1 into sigma 2. This is third. Now you can expand it. W square sigma 1 square. This will become 1 sigma 2 square plus W square sigma 2 square minus 2W sigma 2 square. This will become 2 into W correlation coefficient sigma 1 sigma 2 minus 2W square, this 1 2 sigma 1 sigma 2. This is fourth. Is this okay? Now if we have to maximize, we have to find the W star which is efficient for the lowest variance. So what we can do, we can take the derivative of this variance with respect to W. So this will become 2W sigma 1 square. This is 0. This will become 2W sigma 2 square. This will become minus 2 sigma 2 square. This will become 2 correlation coefficient 1 sigma 2. This will become 2 to the 4 sigma 1 2 sigma 1 sigma 2. Is this okay? Fifth. And now we make it equated to 0. So what will happen now, that you take all these 2 will cancel and only 2 will remain here. You take W common here. This will become sigma 1 square plus, there was one W here also. W here also. Sigma 2 square minus 2 1 2 sigma 1 sigma 2 is equal to, when you bring it towards this side, so this will become sigma 2 square minus correlation coefficient 1 2 sigma 1 sigma 2. Therefore your W star which is there, this will become sigma 2 square minus 1 2 sigma 1 sigma 2 divided by sigma 1 square plus sigma 2 square minus 2 correlation coefficient sigma 1 sigma 2. And just to remember this formula, what we can do, we can write it as sigma 2 square minus, this is nothing but this is the covariance of 1 2, and this is 1 square plus 2 square minus 2 into sigma 1 2. Is this okay? So in case, for example, you
Yeah.
forget the formula also, we can calculate this. Okay, directly you put the values and you can find. Okay, and this is known as your minimum variance weight. That for the minimum variance, what will be the optimal weight? Okay, and W2 star will be equal to 1 minus W1 star, straight up. Okay, so these were the main things which were there. And third thing was, so from here we can find W1 and W2. Now, for example, the third concept of the week 8 was that for example, now you are given 3 assets. One is risk-free, another is risky, and this is also risky. Okay, this is RF, this is R1, this is R2, this is equal to 0, this is sigma 1, this is sigma 2. So your expected which will be there. Now, how to solve this kind of question? That first of all, you only consider 2 risky assets. So when you take the 2 risky assets, you find the W star, W1 star and W2 star. So you will get, okay, that what should be the weights of these 2 risky assets in a portfolio. And then this weight total will become, for example, this weight 1 plus weight 2, let's call it, just remain it like this only. So this will become W of F, that is risk free, into RF plus W1 star into R1 plus W2 star into expected R1 and expected R2. And your variance will become of entire portfolio, this will be 0, and variance will be the same which you obtain for a risky part variance. Is this okay, Ulas?
Yes, sir.
Okay. Okay. So these were the three main concepts which are covered in the entire lecture. And what we can do, we can directly jump into the GAs, and there we'll come to know what are the kind of questions which are expected from this week. Okay, the main things I have covered, all things. Okay. Okay. And Sharpe ratio will remain the same. It will be the expected, your total expectation minus RF and divided by your, what is the standard deviation of your portfolio in at all the conditions. Okay, so they had given these are the GS. Okay, so the first question of the GA, they have given the utility function, they have given two assets. One is risk-free with an expected return, and there is a risky asset with an expected return of this, and standard deviation is 15%. So which of the following represents the capital allocation line of the portfolio consisting of these two assets? So we remember we had derived this Cal equation, ERP is equal to RF plus S into sigma C. So here what we do, we first of all find the S, Sharpe ratio. Sharpe ratio is expected RC minus RF by sigma C. So we put it here, we find it is 0.4. Therefore, your ERP is nothing but 0.06 plus 0.4 into sigma C. And this is your Cal equation. Is this okay? Anyone? Any doubt in this?
So directly using formula, right?
Huh. If you have forgotten formula also, then what you can do, you can start here building that formula. And what are the steps? That first of all, you make expected RC is equal to 1 minus WRF plus W into expected of RP. This will become RF plus W into expected of RP minus RF. So this is your first formula which you derive. Second is S is equal to ERP minus R of F divided by sigma of P. Now you put it here, so this will become RF plus W into S into sigma of P. But you also know that your entire this is equal to W into sigma P. So this you replace it with this. So this will become S into sigma C. And this is your Cal equation. Is this okay? Okay.
Yes.
Yeah. Okay. We go to next question. How much of an investor's wealth should be invested in risk-free assets? So here the question is the same. So now we will utilize this utility function. So without remembering the formula, what do? We make the utility function is equal to ERC. So ERC I can write down RF plus W into expected of RP minus RF. This is my this ERC minus 5 sigma C squared. So sigma C is nothing but W square into sigma P square. Now to find the optimal W, I do dou U by dou W, which will become, this will become 0. This will become ERP minus RF. This will become minus 10 into W into sigma P square is equal to 0. Therefore, W is equal to ERP. ERP, they have given 0.12 minus ERF 0.06 divided by 10 into sigma p square. So standard deviation is 0.15. So this will become 1.5 square. And you calculate this, you get the W star. And this W star is for what? It is for the risky asset. And for risk free, it will become 1 minus W star. Is this okay? So without remembering the formula also, we can do this. Okay, I've done the same way. So you've done. Okay. Now we come to next question. What is the standard deviation of the investor's optimal portfolio? So when this word is used, optimal, so it means your variance should be the minimum. Should be minimum. Okay. And for that, what do? You star your W star, W1 star is equal to sigma 2 square minus covariance of 1, 2 by sigma 1 square plus sigma 2 square minus 2 sigma 1, 2. So you put these values, then you will get the optimal portfolio. And once you get W1 and W2, you put it in the formula for the full variance and you will get the standard deviation. Is this okay? Any doubt,
Yes.
in this? Okay.
No doubt.
Okay. Okay. Then there are two risky assets. Now we have come to the two risky asset part that are perfectly negatively correlated with each other. It means sigma 1, 2 is minus 1. Asset,
So excuse me, sir, can you show me the formula which is just about
which formula?
the previous question we were doing this
This
previous
one?
question? Yeah,
Yeah.
this one.
Yes.
Okay, cool.
Okay. So we had derived this formula earlier.
Right, sir.
Okay. Okay. Now we come to the next one. So there are two risky assets that are perfectly negatively correlated with each other. And asset one has an expected return 5%, standard deviation 6%, two 10%, standard deviation of 10%. What are the weights of the assets in the minimum variance portfolio? So in the minimum variance portfolio, what we have to do, we have to find the W star for the minimum variance. So we put the same formula, W square into 0.06 square plus 1 minus W square into 0.1 square minus 2 into W into 1 minus W into sigma AB. This will become, sorry, sigma AB. So this sigma AB, they have given perfectly negative square. So this will become minus 1. So when you put it in the formula, so this is plus, and when you put sigma AB, this will become minus. So when you put this, so it becomes W1 0.06 minus W2 into 0.1 whole square. So your standard deviation will be the absolute value of 0.06 W1 minus 0.1 W2. Okay. So, and what you've done, you have taken the derivation. So 0.06 W1 is equal to 0.1 W2 because sigma 1 W1 is sigma 2 W2. So from here, we have found W1 and we have found W2. Once you have found, so that they had asked the same, that what are the weights? Is this okay, this question with everyone?
Sir, I think can we find the weights earlier, W1 and W2, by that minimum variance formula for weights,
So what I'm doing, okay, basically, yes, okay, you can do that by that also.
right?
Yes. So what I'm trying to do that, okay, in case, okay, we forget the formulas, but still we have to find the solution, we should be able to come up with that.
Hmm.
Okay. So without remembering the formulas, otherwise, immediately you can do that W1 star will be equal to sigma 2 square minus correlation of 1, 2 divided by sigma 1 square plus sigma 2 square minus 2 sigma 1, 2. From here also we can do it. Okay.
Here the correlation value is negative, right? So we can substitute the values and find out W1 and W2, and then we can find out variance.
Yes, yes. So
Right.
that also can be done.
Okay.
Okay.
Yeah.
So I'm just explaining why, because if you forget the formula and you have got the concept, still you can do that. Okay.
But
Yeah.
sigma 1 2 is not given, right?
No, no, they have given a perfectly negatively correlated.
Okay, minus. It will be minus 1.
Minus 1. So it is minus 1. Okay. So what is the minimum standard deviation that can be obtained in a portfolio consisting of these two assets? So this is we had already calculated that it will be sigma 1 W1 minus sigma 2 W2. You put in the weights and you get the answer. Now, second question is, if an investor has a utility function this, what are the weights he assigns to asset 1 and asset 2 respectively in his optimal portfolio? So for this, you have to remember this formula. This formula also can be derived, for example, if you forget that. Okay. And how do we do that? I will just explain to you. I'll take this question. So we have to find the optimal one. So we do U is equal to ER. ER we can write as W into ER1 plus 1 minus W into expected of R2 and minus sigma square. So sigma square is the entire portfolio that. So this I can write as W into sigma 1 square. Sorry, here I am taking 1 minus W. Okay, it's correct. Then 1 minus W square into sigma 2 square plus 2W1 W2 sigma 1 2. And so here A is not given. Okay, so I can make this utility function like this and I can expand this. I know these values, so this will become 0 point something was there. Just hold on, I'll take these values also from here. Okay, so these are the values. Okay, so this has got 0.05. So W 0.05 W plus ER2 is 10%. So 1 minus W into 0.1 minus W square into sigma 1 square. Sigma 1 is 6%. So this will become 0.0036 plus you expand this 1 plus W square minus 2W into sigma 2 is 0.1. So this will become 0.01. This will become 2 into W into 1 minus W into minus 1 because perfectly correlated, uncorrelated. So this is now 0, 0.05 W plus 0.1 minus 0.1 W minus, now you can open this, or this will become 0.036 W square plus 0.01 plus 0.01 W square minus 0.02 W plus this will become, sorry, minus 2 W plus 2 W square. Now you can take derivative of this with W to get 0.05. This is 0. This will become 0.1. This minus here it will become 0.072 W. This is 0. This will become 0.02 W. This will become minus 0.01 minus 2 plus 4 W. This is equal to 0. And then you can find the W star. Is this okay? This way. So we don't have to remember the complicated formulas.
Yes, got it.
Yeah. Thank you. Okay. Now we go to next question. Okay, so an investor has got a utility function this. What are the weights he assigns to asset 1 and asset 2 respectively in his optimal portfolio? Okay, if an investor, so this we have solved. Yeah. What is the expected return of optimal? Put a W and 1 minus W, we'll find this. Okay, now we come to the third question. Next question. There are three uncorrelated assets. So uncorrelated assets mean that there is no correlation. So your W, this sigma 1, 2 is equal to 0, sigma 1, 3 is equal to 0, and sigma 2, 3 is equal to 0. This is the meaning. Asset 1 has an expected return of 5%, and it is a risk-free asset, so the sigma is 0. Asset 2 has an expected return of 10%, standard deviation is 0.1. 3 has got 12%, standard deviation of 16%. Okay. So an investor has invested 60% of wealth in asset 1, 40% in asset 2. What is the Sharpe ratio of this portfolio? So how to go about it? So we know that Sharpe ratio is equal to expected total return from that portfolio minus RF divided by standard deviation of that portfolio. This is one important formula you have to remember. So what we have to calculate? We have to calculate first expected. RF is given. Then we have to calculate the sigma P of this, and then we calculate. So expected RP will become 0.6 into 0.05 because he is doing under asset 1. 0.4 into 0.1. So this comes 0.07. Sigma P will become, this is 0, so this will not be counted. Only 0.4 into this will become 0. Sigma P directly will become 0.4 into 0.1. Why? Because your variance was W1 sigma 1 square plus W2 square sigma 2 square. This is 0. So therefore, if you remove the 2, so you get W2 into sigma 2. So sigma P we get 0.04. Now put it in the formula and we get the Sharpe ratio. Is this okay with everyone?
Sir, why we have not counted asset 3?
Because they have given that okay, we are investing
Okay,
on
yeah,
only
sorry,
asset.
sorry. I just
Okay.
stupid of me, yeah.
Yeah.
So
Okay.
we can do it like 0.1 minus 0.05 divided by 0.1 also.
Uh, how that okay we'll do?
0.1 is like return of asset 2 and minus 0.05 is return of risk-free asset divided by 0.1 standard deviation of asset 2. So that will
No,
also give.
no. So see, they have given okay three assets. So what you are saying that you utilize the same formula, but we have to find this ERC, na?
Right, we need to find the expected return.
Okay, so this is the expected return.
Okay, thank
Okay,
you.
okay, okay.
The
Now we
square
come to
terms
the
gets cancelled, right? For the sigma square, like
huh.
you have written. Okay.
Yeah. So now question number 9. He identifies the uncorrelated asset 3 and wants to diversify his risk exposure. So till now he was investing in 1 and 2. Now he says, I will also do some investment in asset 3. He pools the risk and makes a portfolio with 20% in asset 1, 40% in asset 2, and 40% in asset 3. Now, what is the standard deviation and the Sharpe ratio of the risk pooling profile? So in this, what we have to do, first we find the total expected. So expected we can make because weights are given. So we get, for example, 9.8%. Second, we find now the full variance of the entire portfolio. So for asset 1, it is 0. For asset 2 will be 0.4 into 0.1 square plus 0.4 into 0.16 square because they have been given to us. So we get for the entire portfolio, we get around sigma, we get 0.0754. Now you put it in the formula for the Sharpe ratio, expected total return minus RF divided by the standard deviation of the portfolio. So expected return we know We know the RF has been given to us and we have calculated. So we have found the RSEC value. Is this okay?
Okay.
Yeah. Okay.
How
Now
long will
he,
this get square?
yeah. Okay. Okay. So now we had solved this. So this was the one. Now what he is saying, now he creates a new risk sharing portfolio by putting 60% in asset one, 20% in asset two, and 20% in asset three. So what is the standard deviation and the Sharpe ratio? So again, we will do the same method, find ER, find sigma P, and then you use ER minus RF divided by sigma P. Okay. So it's the same steps and
Just a
you get,
probability change.
yeah, and you get the same 64%, 0.6366. And if I'm not wrong, earlier also it was the same value, 0.6366. So your Sharpe ratio does not change. Okay. Now is the next question. Ramesh is a risk-averse investor with a utility function they have given. He can invest in three types of assets: government bonds, which are risk-free assets, corporate debt, and equities. They both are risky. The government bond has a risk-free rate of 5% and sigma will be equal to 0. Return on corporate RD has an expected 10%. Standard deviation is 8%. Equities is 20% and sigma is 25%. They have given the correlation also between the corporate and debt equity is sigma DE is equal to 0.25. So what is the smallest possible variance of a portfolio consisting only of debt and equity? Okay. So we have to follow the same principle what we did earlier. What we did earlier, we consisted of, so I'll just paste it here and explain this. So I will consider only the portfolio with debt and equity. Both are risky. So expected return will be equal to W into corporate has got how much? 0.1 plus 1 minus W into 0.2. This is the expected. And your sigma square will become 0.01 W square plus 0.04 plus 0.04 W square minus 2 into 2, 0.04 into 2, 0.08 W square. This I have expanded. And then we get 2 into W, 1 minus W, and PDE they have given. So this is the correlation coefficient. This is not covariance. So this will become 0.25 into 0.08 into 0.25. Has everyone understood okay, this equation?
Yes.
Okay. And from here, we can directly find the W star. So either you can use the formula also that you use the WA star is equal to sigma B star minus covariance of AB divided by sigma A square plus sigma B square minus 2 of AB. So you put the values here, sigma B square, sigma B is what? 0.25. So 0.25 square minus this is nothing but the correlation coefficient into this minus 0.25 into 0.08 into 0.25 and put the values here. This is 0.08 square plus 0.25 square minus 2 into 0.25 into 0.8 into 0.25. So this W1 you will get okay for this. You get W2. So first and now putting once you have found, then you can find the smallest ratio. So that will become, you put in this formula. Is this okay?
Sir, just a naive question if I can ask.
Yeah, please.
I hope I am not too irritating.
No, no, not at all, not at all.
Just one question. What was the difference between this formula? This is the standard formula that we have for minimum variance portfolio, and the other formula that is A that is A in it.
So there, what we try to do, there again, the utility function is given and we try to maximize the utility. So we are finding the W star to maximize the utility.
Okay.
Here we are finding the W star, which is minimizing the variance.
Okay.
Okay, and I will just tell you what is the relation between this question and earlier questions. That what you do, so you have got three assets, A, B, C. These are risk-free. Sorry, risky. This is risky. And this is risk-free. So what you do, first of all, you take the combination of these two assets and find the W1 and W2. Okay. And
Right.
now you know and you can find the ERC also of this. Now, in the next step, what you do, you include A also, and now your total return of portfolio will be equal to W into RF plus 1 minus W into this ERC.
Right.
Okay, second, the total variance of this will become this 0 and only the variance of this, which you have already calculated. You have calculated here. Okay, so steps is find W1 star, for example, this is W1, W2, W1 star, W2 star. Then using that, you find these two values. And now you include A also, and you find ERP and sigma square. And then your S will become ERP minus RF divided by sigma P. Is this okay?
Perfect. Thank
Okay.
you.
Yeah, steps. Okay. So good. So these are the same steps which we have done earlier. So I have not used the formula. I have calculated directly, just putting the W values, and I got okay, the answer. So we have got this answer, a standard deviation. Okay. And they have also asked okay, Sharpe ratio. So I have calculated ER, I have calculated the variance, I have calculated the Sharpe ratio. Now, what they have asked that what are the respective weights of debt and equity in the optimal risky portfolio. Okay, optimal risky portfolio. So here, whenever the word optimal risky portfolio comes, here your utility function comes into the picture. So he had given the utility function ER minus 10 sigma square, ER minus 10 sigma square. So whenever you are saying optimally risky portfolio, there you try to find the W from here. Either you can use this formula, which is slightly complicated, or you can put the values of this ER which is there. Now you know the ER क्या हमने निकाला हुआ है सिग्मा और या ER का फॉर्मूला लगा सकते हैं वहां पर या आप क्या इसको एक ये फॉर्मूला है it is W2 star is equal to RD minus RF. This is known as RD into sigma of E square minus RE minus RF, which is known as RE into sigma D, sigma E, and your correlation coefficient, same RD, RE, summation of this, and minus RD, RE into sigma D. So this is one formula, slightly complicated, so that we have to find out. Is that okay?
Whenever they ask optimal risky, right?
Optimal risk.
Okay.
If you forget this formula also, you can do this question. Okay. So what you do from here, now you have found the, for example, respective weights of debt and equity. So it is asking only about the debts and equity. So if you forget this, so I will just try to explain how you can still get the answer. So you can do in the same way, E is equal to ER minus tan sigma square. So your ER is nothing, is W into RD, expected RD, this is debt fund, plus 1 minus W into expected of RE. These two values are given to us, so we can replace this, minus tan sigma square, which is there. Now out of sigma, this tan sigma square, you put sigma W into sigma D square plus 1 minus W sigma E square plus 2 into W into 1 minus W into correlation coefficient DE and sigma D sigma E. And you know these values, you just put the values and take the derivative with respect to this, equate it to 0, and you will get W star. Is that okay? Like what we used to do earlier? Is this okay? Or should I?
Yeah.
Okay. Yeah. So this is not so difficult. Okay. Then we have to find the Sharpe ratio of the optimal risk. So it is straight away expected minus RF, it has been given, and the standard deviation of the portfolio. Okay, so we have got this. Now suppose Ramesh constructs a portfolio with an expected return of 15% by combining only debt and equities. So it is very easy. You just make 0.15 is equal to W into 0.1 and 1 minus W into 0.2. Solve for W, so you will get the W of the debt. And then you get 1 by W for the equity. This is easy. And then they have asked for the standard deviation also. So you put it in the formula of variance and you get that. Okay. Now what they say that now suppose Ramesh constructs a portfolio with an expected return of 15% by combining bonds, debt, and equity. They are saying that now they will combine everything. So what are the portfolio weights for the three assets? So how do you solve this? So 0.15 will become weight of risk-free and 1 minus W into risky asset. And this risky asset, we have already calculated that risky assets when we are combining earlier. So we had found okay, that was 0.123. So this has come from here, from the optimally risk portfolio. This is the return of the debt and equity. And you have to use this and its standard deviation for the remaining part. So here you put 0.123, which is the combined return of debt and equity. You find the W. So W will come for the risk-free. 1 minus W, which will come. So 1 minus W, for example, will come 1.37. This has come in negative. So you do 1 minus 0.37. It will become 1.37. And we had found the weights of debt and equity, which was 0.77 and 0.23. You multiply by this. Now you get the weights for the new weights for the portfolio consisting three assets. Is this okay? Or shall I cover the steps again?
It's clear.
Okay. Sharpe ratio, ER minus RF by sigma P. Okay. Now, what is the Sharpe ratio of the optimal portfolio consisting of all three assets, bonds, debt, and equity? So remember, bonds ka is 0. So debt and equity ka, whatever the standard deviation you had got or the Sharpe ratio which you had got, it will remain the same. You have to put the values. So with this, I have finished the GA. Any question about the week 8? Or shall I cover the basics just in a nutshell? So I will cover here.
Yeah.
So first scenario is risky plus risk-free asset. Okay. This is RF, sigma is equal to 0. This is, for example, RP, sigma is sigma P, for example. So in this case, your expected RC is equal to 1 minus W into ERP, sorry, plus W into RF, and this will become RF plus W into ERP minus RF. Okay. And you define Sharpe ratio is equal to ERP minus RF divided by sigma P. You replace this in 1. So your 1 will become ERC is equal to RF plus W into S into sigma P. Now, if you calculate sigma here, it will become sigma of the entire portfolio, which I'm denoting by C. This will become 0 square plus this will become W square sigma P square. Therefore, your sigma C is nothing but W into sigma P. This you replace it here. So ERC becomes RF plus S into sigma C. So this is known as your Cal equation. Okay. Number 2, if some utility function has been given to you, so utility function is generally, it is like this, ERC minus half A sigma square. So then they will ask you that find weights for optimal solution. So in this case, these weights which are there, if you do the formula, I'll give you the straight away this formula, it will become ERC minus RF divided by A into sigma P square. Okay, so this straight away you can get this weight, and this weight will be for the risky asset. Okay, or you can, if you forget the formula, then what you can do, you put these values here in ERC. You can do RF plus W into ERC minus RF and minus half into A. This sigma which is there, you know that it is sigma of P whole square. And then you can take the derivative of this with respect to W, and then you will get the answer. Okay, and this will become W square sigma P square. So this is first. Then the second part is two risky assets. Your ERC is equal to W into RD, that plus 1 minus W into R equity expected. And sigma square is equal to W square into sigma D square plus 1 minus W square sigma E square plus 2W1, W2 and covariance of D and E. Okay. And from here, you can find either they will ask you minimum variance. So minimum variance, you do the derivative of this with respect to W to find the W star. Second question, they ask for optimal. So in the optimal, they will give you a utility function. So again, what you can do, you can put in the utility function and you can find the best W star. Okay. Third part is that you got one risk-free and two risky assets, and you have to find the weights. So in this, steps are consider only two risky assets. Okay, calculate their weights, W star, W1 star and W2 star, then find ERC, find sigma C square. Now, using this, now you find the entire portfolio RP is equal to W into RF plus 1 minus W into this ERC which you have calculated. So from here you will get a W star, and you will get 1 minus W star for both equity and this. And इसको आप जब multiply करेंगे to W1 star into W2 star, you will get for debt and equity. Is this okay? This understanding? Any doubt? Okay, anyone? I hope I am audible.
Yeah, sir. Please.
Yeah. Okay. So with this, shall we go to PYQ then? Okay, we have solved it.
Yeah, we can move to PYQs.
Yeah. Okay. 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 So this is the first question. Robert has a mean variance. Oh, this is a PYQ or this is GA? I think this is okay. Let it be anything. Okay. Robert has a mean variance preference represented by the utility function this, where this is the this. Okay. He's considering two assets A and B. Asset A has 10% 0.25 probability and a 20% rate of return with 0.75 probability. Whereas asset B has a 25% rate of return with 0.50 probability and a 5% of return with 0.50 probability. Which asset would Robert prefer? So what we have to do, we have to find the expected of A, use the probabilities and returns, so we get one value, and we find the expected B, this 0.15. So expected of A is more than expected B, so therefore we will select A. Okay. But in this question, while solving this, we have not considered okay, this U. So we had to use this U also. Okay. Okay. Second is what would be the fair price of a bat that pays 2 with a 25% probability, pays 4 with a 50% probability, and pays 8 with a 25% probability. So straight away we put the probabilities, find the expected value, which comes 4.5. Next is suppose a 1-year government bond is offering a 10% rate. Ankit has 10,000 which he can invest in government bonds or lend to his friend Suresh. Suresh will pay back the promised amount with an 80% probability and will pay back nothing with a 20% probability. So what is the default premium that Ankit should ask from Suresh? So what we do, we find first of all the return in a risk-free, which is 10,000 into 1 plus R, 1 plus 0.1, this is 11,000. And this should be equal to 0.8 into 10,000 1 plus R, suppose he's charging R, plus 0. So from here, the rate of return comes 0.375, that is 37.5. And now remember the default premium by definition is your rate which you are charging minus risk-free rate. So this will become 0.375 minus 0.1. So this becomes 0.275. Is this okay?
Yes.
Okay. Okay. Next one is Axis Bank has an asset of 1,000 units, liability 750, capital 250. What is the leverage ratio of Axis Bank? So leverage ratio is nothing but your asset over capital. So we calculate it is 4. The next question is there are two assets, a risk-free asset that offers a 5% return and a risky asset that has an expected return of 15% and a standard deviation of 10%. What is the slope of the budget line of a portfolio consisting of these two assets? So this slope which is there, it is nothing but it is the Sharpe ratio. Okay. So you calculate the Sharpe ratio ERC minus RF by sigma, everything is given and it comes 1. Is this okay?
Yes.
Okay. Next, an asset has a correlation of 0.2 with the market and a standard deviation of 20%. If the market return has a standard deviation of 5%, what is the beta of asset A? So this has not been covered in our syllabus. So we have to remember the beta or beta we can definition is beta of A is equal to correlation coefficient of AB into sigma A over sigma B. So this is the formula. Okay, so this, please remember this formula. So this will become beta AB is 0.2. This is 0.2 over 0.05. This will become 0.8. Is this okay? Beta formula?
Sir, but what in general, what does beta mean? Was
I have not tried to find out. I will.
and none of the GA questions also had.
So it has never not been covered in any one of the lecture also. है ना?
Yeah.
Yeah. So okay. Now, what is short selling? So short selling, yesterday I had explained during the lecture that short selling is once when you borrow. So first step in the short selling is borrow, then sell, then third is purchase, and fourth is return back. So these are the steps of short selling. So short selling is selling stocks you don't own in the hope of buying them back at a lower price. So this is the short selling. Okay, the next question is you create a portfolio of 16 identical assets that have an expected return of 20% and standard deviation is 20%. These 16 assets are uncorrelated with each other. It means your sigma ij is equal to 0 for all I and j, and I not equal to j. Okay. What is the standard deviation of your portfolio? So we put the same formula, sigma square p is equal to wi sigma I square for all I plus 2 sigma ij wij into sigma ij. So this entire term becomes 0. So this will become summation of wi sigma I square. So we got 16. W is become 16 weights is become 1 by 16 square into 0.2 square. So this 0.2 square by 16 and answer we get 5%, 0.05. Is this okay with everyone?
Yeah, got it.
Yeah. Okay. Okay, which of the following statement is incorrect? The minimum variance set is a subset of the feasible set. So this is true that whatever the sets are there, the minimum variance is also subset of this. The minimum variance set is the left boundary of a feasible set. This is also true because this was the thing which was covered in the lecture that when you make, so this is the left side of this, of the GMM which you get. The risk-averse investors always choose the global minimum variance portfolio as their optimal portfolio. It is false. It depends on their utility function. Okay, so it might be here also. They might choose here also if he has got some risk appetite. The efficient frontier is a subset of the minimal variance set. This is true. Okay, if the utility function of an individual is strictly concave function, then individual is what? So this is straight away from the theoretical part. So if there is a concave function, so concave functions we know it is like x 1 by 2. So your f is equal to this d square by f by dx into dx square will become minus 1 by 2. So if it is negative, then it is a risk averse person. A borrower is called solvent when his assets are less than liabilities. Liabilities. Straight away. Okay. Then there is a question of a garment outlet can be worth 60,000 in 2 years with a 25% probability or 150,000 in 2 years with a 75% probability. The appropriate cost of capital is 10%. What is the present value? So first of all, we find the expected value with these probabilities, 0.25 into 60 plus 0.75 into 150. So this comes around 0.1275. So this is the expected value, 1,27,500. And to find the present value, it is in 2 years. So it will become 1 plus 0.1 square. So you get 1,27,500 by 1.21. Is this okay? This is from our previous concepts. Is this okay, Suraj?
Yeah, clear.
Yeah. Okay. Which of the following statements is correct? Equity owners are paid first and then the debt is paid off. So this is false. So this is from the mortgage and debt fund concept that you are starting a business. You have put your own money, for example, some equity, and you have taken some mortgage. So what happens when anything comes first, the mortgage is paid. So this is false. Equity owners bears less risk in comparison to debt creditors. So this is also false. It is he also bears the same risk, which is there for the creditor. Equity ownership is an example of limited liability. This is true because his liability, for example, he has started a business of 1 lakh by just investing 5,000 and taking a loan of 95,000. So he is reducing his liability. Equity financing does not provide ownership rights. This is also false. He has got ownership in percentage. Okay. Next one is at an optimal consumption point, the slope of the budget line is more than the marginal rate of substitution. Wrong. It is equal. So this is your budget line and this is your indifference curve. And at the optimal, your MRS, which is there, it is same. The marginal utility of the goods is same for both. Oh, sorry, this budget line is tangent to the indifference curve. I just explained this one. Okay, next question. If the risk-free rate of return is 6% and the expected market rate return is 12%, if the beta of an asset is 2, then what is the expected return of the asset according to the capital asset pricing formula? Fortunately, they have given the formula here with the beta. So they have given Ri is equal to Rf plus beta into Rm minus Rf. Straight away you put the values and you get the answer. Okay.
So we'll get this formula in the paper itself.
They have given in the PYQ, they have given this formula. Otherwise, the formula is Ri is equal to total is Rf plus W into Rm minus Rf. Okay, so this beta is nothing but is the W here.
Right.
Okay. Now, next question is, suppose there are 4 assets there that are uncorrelated. So this Wij becomes 0. One may invest in any of one in or any combination. The mean rate of return is 10%, and it is same for each of the assets. The variances are different. So these are the variances. So what is the minimum variance that can be obtained in portfolio consisting of these 4 assets? So remember this we can use by 2 methods. One is straight away there is a formula that if they are uncorrelated, then your sigma square is equal to 1 divided by summation of 1 by sigma square. Okay. So this is one formula. You use this formula, you'll get the answer. In case during the exam you forget this formula, for example, then you can use it, solve it using Lagrange also. So Lagrange, what it does, we have to do the minimum variance. So we have to minimize this, minimize variance such that the summation of your weights is 1. This is the condition. So we have got 4 variables, but we have got only 2 equations. So we make a Lagrange function from here. So Lagrange will become, I have put together this, these are wrong, 0. So this will become 0.1 W square plus 0.2 W square, 0.3 W square, 0.4 W4 square minus nu into this is your return. So we are also to maximize the return also. Minus we have to this lambda W1 plus W2 plus W3 plus W4 minus 1 is equal to 0. So this is the Lagrange. Now you take its derivative with respect to W1, W2, W3, W4. So you get the function when you do for W1, 0.1 nu minus lambda is equal to 0.2 W1. When you do for W2, you get 0.4 W2. Then you get 0.6 W3. Then you get 0.8 W4. So it means your all these values are same. 0.2 W1 is equal to 0.4 W2 is equal to 0.6 W3 is equal to 0.8 W4. So from here, now you can calculate W1, W2, W3, and W4. Now put this W1, W2, W3, W4 into your variance equation and you get the answer. So I have given you both. Okay, I have given you the formula also, and I have given you the way also how to calculate Lagrange also. Is that okay? Okay, this next question is straight away from the GA question. We have got a GA similar question in the GA. So please try to solve that and you will get this answer. Okay, I think with this, can we call it off? It is slightly become lengthy. You try to solve these 4-5 questions. They are easy.
Yeah, sure.
And in case you find any difficulty, you can post on WhatsApp and I'll solve it. Okay?
Yeah, sure.
Yeah.
Yeah.
Okay, bye-bye. Thank you for joining. Have a very nice day and all the very best.
Thank you, sir. Thank you.
Thank you, sir.
One small doubt
Yeah.
before calling.